So let's sketch a graph of y equals, how about let's do secant of x over 3. So first of all, let's decide what happens to the graph, and we'll go ahead and put it in our calculators too. But what this does to the graph is this is the same as 1/3 x. 1/3 x, so if I did my whole business with the period, the new period would be 2 pi divided by b, right? The new period of this would be 2 pi divided by 1/3. Dividing by a fraction is the same as multiplying by its reciprocal, right? So what's the new period? 6 pi. So I had an old period of 2 pi, and now it's stretched to 6 pi. This is a horizontal stretch of 3. What that helps me do is, what I can take then is some of the old asymptotes, and I can stretch them by 3. The way you stretch them by 3 is you multiply them by 3. And so if I'm stretching this way horizontally, that's going to spread the asymptotes out. So there's going to be more space in between them. So I'm going to just take a couple of them and see if I can find a pattern. Do you see on my old graph I had an asymptote at -3 pi halves? If I multiply that by 3, it becomes -9 pi halves, which isn't that just -4.5 pi? Okay, and then I had another one that was at -pi halves. Let's multiply that by 3, and that becomes, that's -1.5 pi. You following? And then there's another, I have another one at pi halves. I multiply that by 3, and it occurs at 3 pi halves now. So, okay. I'm just giving you some helps so when I'm graphing it on my calculator and transferring the graph, that I know what it is. Okay, so those are some of my new asymptotes then. Alright, so I'm going to make sure I make a note of that. I am going to type it in my calculator, and then I'm going to sketch a new graph. So the way I type this in my calculator is it's still 1 over cosine, but I changed this to an x divided by 3 instead. And I'm going to show the window of -2 pi to 2 pi, but you're going to see what's going to happen is it's way stretched out now. Do you see that? I kept it on the same window as before, but because it's now a period of 6 pi, it's way stretched out. So what should we maybe change our window to? Well, if the period is 6 pi, shouldn't I maybe do -6 pi to 6 pi instead? Okay. Alrighty. So, you guys still, you have that up? You don't have that up on your calculator. So since secant is loci, I typed 1 over cosine of x over 3. Okay. Oh, I'm not going to, that's silly. Why would I do that? I'm going to put this on the grid. Alright, I'm trying to squeeze this in here. On my graph above, I made every, because this is the wide grid paper, I made every tick mark a pi, didn't I? I'm going to make every tick mark a 2 pi here. that's negative 2 pi, negative 4 pi, negative 6 pi. Okay, so let's put some asymptotes on here. Let's put one at negative 4.5 pi. That would be halfway in between negative 4 pi and negative 5 pi. I'm going to then put another one at negative 1.5 pi, which would be halfway in between negative 1 and negative 2. I'm going to put another one at positive 1.5 pi and positive 4.5 pi. Do the maximums and minimums change at all? No, there's no vertical stretch, so I'm still going to have my minimums at 1 and my maximums at negative 1. And so secant is in the middle, meaning that it is even, and the u's alternate. Okay, so if you kind of compare that with the graph then that we did on our calculator, then they look the same, but they're labeled appropriately.